In this video, I am going to explain how to find out LCS of two sequences. So LCS stands for longest common subsequence. To find out LCS of two sequences, we have to use a designing technique, that is algorithm designing technique, dynamic programming designing technique. By using dynamic programming designing technique, we can solve an LCS problem. So to find out LCS of two sequence, we consider X is a sequence. Suppose X equal to A, B, C, B, D, A, B. This is one sequence. Another sequence Y equal to, that is B, D, C, A, B, A. These are two sequences. If two sequences are given, how to find out LCS? So first you find the length of first sequence, that is M equal to length of X, this is equal to 7. Then N equal to length of Y, this is equal to 6. So first you have to find out length of first sequence, that is M equal to length of X equal to 7 and N equal to length of Y, that is equal to 6. Since the first sequence length is 7 and second sequence length is 6, so to solve this problem we have to use a table whose row size equal to M plus 1, this is row size, and the column size will be N plus 1. So you have to remember how can you create the table, or what will be the table size. If first sequence, first find out the length of first sequence, then second sequence, the first sequence length plus 1, it will be row size, second sequence plus 1 will be column size. So to solve this problem, when you design a table, the row size will be N plus 1 and column size equal to N plus 1, and row index starting from 0 to M, column index starting from 0 to N. Now how to identify element of each sequence. Suppose we consider X is a sequence, how can I identify A, B, C, B, D, A, B, etc.? So x1 equal to x of 1 equal to A, that means first element, this is subscript 1, x1 equal to x of 1 equal to A. Similarly x2 equal to B, x3 equal to C, x4 equal to B, x5 equal to D, x6 equal to A, and x7 equal to B. So in this way we can access, or we can identify the elements of first sequence. Similarly for second sequence, y subscript 1 means that is y of 1, that is first element, B, then y2, D, y3, C, y4, A, y5, B, and y6 equal to A. In this way we can identify the elements of two sequence. Now you see why we use a table like this, because if you want to solve the LCS problem, you have to use two tables. One is C table, another is B table. So what is C table and what is B table? C table is used to store the LCS length. It is used to store LCS length. And B table, it is used to compute LCS quickly. That's why we use two tables. What is the use of first table? First table is called C table, which is used to store LCS length. B table, it is used to compute LCS quickly. So what is the size of C table? C table size M plus 1, that means the index starting from row index starting from 0 to M and column index starting from 0 to N. This is the nothing but two-dimensional array. Similarly, for B table, row starting from 1 to m, column starting from 1 to m. Since C table and B table, these two tables are used to solve this problem. For our simplicity, we have to take a single table which represents C table as well as B table. The entry of C table of ith row and jth column is nothing but C of ij, and the entry of B table, that is ith row and jth column, equal to this one. That means if I want to access any entry, first you have to write the C. For C table we write C, for B table we write B. That means it is a two-dimensional array. It is also B is a two-dimensional array. To access each element means ith row and jth column element, we can write C of ij. Similarly, B of ij. So what is the use of C table and B table? I have already told C table is used to store the length of the LCS and B table is used to store three arrows. One is winding, another is up arrow, another is slipping arrow or left arrow. Now you see the process. First, you design a table like this. You take the first sequence elements row wise, second sequence element column wise, index starts from 0 to 6, index starts from 0 to 7. For row index I use I, and for column index I use j. And since suppose from the two sequences x length is 0, then automatically LCS will be 0 for two sequence. That's why I have initialized the top row by 0 and the left column by 0. Now, after initialization of top row and left column, how to find out the value of each box? Since it represents B table as well as C table, so each box holds two values, one value for C table and another value for B table. So what is the procedure to find out the value for each entry? Suppose this is j column, this is I row, this is j minus 1 and this is I minus 1. So for C table, this box is C of ij, or this entry is C of ij. For B table, it is B of ij. If this value and this value are given, how can you find out this one? So suppose here we consider the column element yj and the row element xi. How can you fill up the table? First you see xi equal to yj means row element equal to column element. If row element equal to column element, then at that time you consider the diagonal neighbor box value plus 1. That means in this case C of ij equal to C of I minus 1 comma j minus 1 plus 1. If xi equal to yj, C of ij equal to C of I minus 1 j minus 1 plus 1 means this value plus 1. And what will be the value of bij? Bij equal to winding. You store the slanting arrow or winding. If xi is not equal to yj, this one is not equal to this one, at that time you consider top element or the box above and the box left. If the value of box above is greater than or equal to value of box left, at that time you consider this value and use up arrow. If this condition falls, you have to use left box value and use slipping arrow. That means if xi is not equal to yj and C of I minus 1 comma j is greater than or equal to C of I comma j minus 1. This is the box above, this is the box left. If this condition is true, then C of ij equal to C of I minus 1 comma j. That means you consider this value here. And what is b of ij? B of ij equal to upper. Similarly, if this condition is false, then C of ij equal to C of ij equal to C of I comma j minus 1, and B of ij equal to which arrow? This is sleeping arrow. You remember three things. If characters are same, C of ij equal to quadrant value plus 1, arrow equal to this one. If this condition false, if this one is greater than or equal to this one, then you consider this value here and use up arrow. If this condition false, you consider the left box value, then use sleeping arrow. So according to that, we fill up the table like this. Now you see here 1, here the letter is B, here A. Since B and A are not same, at that time you consider left and above column. The box above and the box left. So this value is greater than or equal to this value. Yes. So use 0. Use this value. Use up arrow. Then again you see for this value, since D and A are not same, you consider this value equal to this value. So use this symbol, the above box value with this one. Then C, A, these are not same. Since C and A are not same, you consider this one and this one. So this value equal to this value. So use this one, then this one. Then A, these are same. Since these are same, so you consider the diagonal neighbor value plus 1, that is 1, then slanting arrow. Then B, A, not same, you consider left and this, above and left. Above is greater than or equal to left, no, so you consider left, then use sleeping arrow. Then A, same, here you consider diagonal element plus 1, that is 0 plus 1, 1, then you use slanting arrow. In this way you can fill up the table. You see, next element, for next element you compare B equal to B. So diagonal element plus 1, use this symbol. Then D, B, not same, you consider this element, left value is greater, so you take 1, then use sleeping arrow. Then you consider C and B, these are not same, so you consider two elements. Since this one is greater, so you write the left cell value or left box value, then sleeping arrow. Then you see A, B not same, A 1, 1 same. So since this value is greater than or equal to this one, you consider this one, then upper. Then B, B same, so you consider diagonal element plus 1, that is 2, then slanting arrow or windings. Then A, B, these are not same, that's why the value is you consider above and left. Since this one is not greater than or equal to this one, you consider the left, then use sleeping arrow. In this way you fill up the, then after completion of this table, now how to find out the length of the LCS and how to reconstruct the elements of LCS. Now you see, after completion of the table, the lower right hand side corner box, that means this box, holds the length of LCS. So here 4 is the value, so length of LCS equal to 4. You have to remember, if you want to find out the length of which box will give the length of the LCS, this, that means C of m comma n, that is equal to C of 7 comma 6 equal to 4. So this is the length of LCS. This value gives the length of LCS. Clear? So after finding the length, if you want to reconstruct the elements of LCS, just you consider the box which is lower right hand side corner. That means you consider this box, and now you follows the arrows of V of I J. That means you see the B table. So when we see the B table stores slanting line or windings, up arrow and left arrow. So for slanting arrow or for winding, for each winding or slanting arrow on the path, each slanting arrow on the path corresponds to an entry for which xi equal to yj. At that time, that letter represents the LCS letter. That means when you start from lower right corner box, according to the arrow, you move from bottom to top. When you will see the slanting arrow or the winding, at that time, this arrow, for each arrow, the entry corresponds to, for each arrow on the path, entry corresponds to xi equal to yj. That means you remember, if when you encounter slanting arrow, at that time you see the column letter and row letter, so that letter will be the member of LCS. You start from this one. For up arrow means you go to this one. Then this is slanting arrow, so you have got slanting arrow. At that time you see A, here is A, so A is the member of LCS. Then slanting arrow means you go to this one. Then this is standing arrow or up arrow means you go to this one. Then you will find again slanting arrow or winding. So at that time you see column letter, row letter, same, so you round. Now B is the member of LCS. Then this is slanting arrow, so it will go to this one. Then this is slipping arrow, it will go to this one. Then this is slanting arrow or winding. At that time you see the letter C, these are same. So C is the member of LCS. Then 2, slanting arrow means it will go to this one, slipping arrow means it will go to this one. Again here we will find the slanting arrow or windings. You see the letter B, these are same, so B is the member of LCS. Then since this is slanting arrow, you go to this. So in this case, your J equal to 0. You have to remember, if I equal to 0 or J equal to 0, you stop the process for finding the characters of LCS. Now, what are the LCS? What are the elements of LCS? So LCS equal to B C B A. B C B A means that is x2, x3, x4 and x6. x2 equal to B, x3 equal to C, x4 equal to B. That means BCBA is the longest common subsequence, and the length of longest common subsequence is 4. So this is the problem regarding LCS.